Sharing the screen. Sharing the screen. Okay. Woo! So let's get started. Monitor. Sorry, I'm all out of sorts today. As I'm doing these, I'm just gonna actually kind of choose random ones from like the problem set numbers you've been doing. So if you have them handy, great. If not, you can just write them down and then kind of go back and check. But I will try to write the numbers down that I do, just so you have something as reference. And we'll go from there. But hopefully, like, the first page maybe shouldn't have been too bad. I'm picking random ones. So once again, I'll just go to kind of each section and try one or two. I will always stop and kind of see if there's questions. If you're at home, feel free to throw a question in the chat, or you can just always interrupt me and we'll go from there. All right, good old eyes. So we're talking about imaginary numbers. Imaginary numbers we need when we have a negative under a square root. So I'm just picking a random one. So once again, I'm doing these from the thing, but you don't need to have it in front of you. You can just write them down as we go if you like. So I picked this one just as kind of a basic one, just to remind us, anytime you see the square root of a negative number, you're saying, ooh, can't have that. This is like the big no, you can't have. So we take care of that by using the imaginary number of I, and I equals the square root of -1. So basically what you can do is anytime you see a negative under a square root, you basically just take the square root of that number of 25, which we know is 5, but that I is representing, the negative under the square root. So that's basically how you would simplify the square root of -25. We're combining it with -7i, and then it's really, you can just combine like terms, so that would be -2i. Exciting stuff. So I just picked a random one. Main goal, just make sure you know that negative turns into that I. That's the big thing. So a lot of the other ones, we're just really combining like terms. I feel like sometimes you get to one, I'm just doing random ones again, like number 22. And I'm going to be posting the answers to these as well, so that'll give you some time to kind of check and see if there's other stuff you want to go over. So let's say you get to 22, you're like, all right, I need to start, I want to try to add these, but before I add them, I have to take care of the radicals. So I'm going to deal with that first. So what I usually do is I rewrite this as 5i square root of 24 plus 3i square root of 18, and then I break them down. If you can kind of do it in one step, go for it. I just tried one. Sometimes I tend to skip steps and then like confuse myself more. So what would that break down to? Oops, what am I doing here? This is Sherman. 4 and 6. So that would be 2 square root of 6. But remember that 5i is up here, so I'm just going to bring it down. This would be 3 square root of 2. I'm going to bring that 3i down. So it's really more about staying organized as you're doing these. So that would give me 10i square root of 6 plus 9i square root of 2. And I feel like people want to be like, okay, well, now let's add them. But remember, we cannot add these. To add two radicals, they have to be the same number underneath. So in this case, that would just be your answer. So I feel like sometimes you do those ones and you're like, I don't think I'm right. I can't actually add anything. That's okay. You just do your best to simplify as much as you can. And then from there, if they have to stay as separate terms, then that is life, my friends. Any problems or questions so far? So I'm looking at the chat. Okay, feel free to interrupt. So I'm just kind of going on. So once again, adding and subtracting is really combining like terms. In order to combine things that are alike, one, you have to take care of if you have negatives underneath the square root. And then if you are trying to add or subtract, your radicals do need to be the same. In that case, I just threw that one on because they weren't the same, and I feel like sometimes you kind of second guess yourself. So then we got into some multiplying, and there was all sorts of fun stuff going on. The big thing with multiplying that I just want to remind you, because it's one of those things like human nature, you want to do something like, let me just find one. Let's say I'm doing 32. You have 2 square root of -12 times -3 square root of -3. Like I see multiplication, I just want to start multiplying. Like, oh, let's do 2 times -3. What can't happen is you can't do the negative 12 times the negative 3. You have to take care of the I first. And I feel like sometimes just you want to multiply and make two negatives a positive. Don't do that. So I would rewrite this as 2I squared root of 12 times, I don't really need the parentheses, negative 3I square root of 3. This can be broken down, so break down things as much as you possibly can. So that would be what, 2 root 3, and out here we had 2I.
All right, folks, should we start going over this? Number 85 or something?
Okay, so we have, oh my God, there's a lot going on here. So what is this? 4I root 3 times negative 3I root 3. Actually, I will put that in parentheses because that times is freaking me out. Now I can multiply. So you want to always make sure you're simplifying as much as possible, that you take care of those negatives by putting i's. That's a big thing. So now let's multiply. 4 times negative 3 is negative 12. I times I is I squared. And the square root of 3 times the square root of 3, I'll just write it as the square root of 9, but we know that that's 3. So I can just kind of write it like that. And then the big thing that we've talked about, and it was in almost, I feel like it pops up in almost every problem. When you see I squared, you replace it with negative 1. So in this case, it's really negative 12 times negative 1 times 3, which would end up being just positive 36. Oh, that works to get a nice little answer like that. But multiplication pops up. You're going to see it. We've multiplied radicals before. But taking care of those negatives by putting the I first before you multiply is going to be a big find. So just as a heads up. Any probs? Any probs at home? Okay, so if you saw one and you're like, dude, I had no clue how to do like 27, just shout it out. I'll be happy to do whatever ones you need. I'm a little bit more multiplying because I know this pops up. I'm just trying to find something like, I'm going to go, I don't want that one. Sorry, I'm trying to, I guess I can do 50. We'll do 55. Sorry, I'm just picking randos. I feel like kind of the multiplying, the adding, it's all just like combining like term stuff. Once we get to the dividing, it was a little different, so we'll do that a little more today. But just to warm our brains up here. So when I look at this, I know I'm going to be distributing because it's just so you know, you see parentheses, you start distributing. Before I distribute, I do have to take care of this. So anytime you see a negative under square root, you take care of that first. I'm too lazy to rewrite this. So I'm going to write this as I root 10 because the 10 can't be broken down. Get a little lazy there. So now let's distribute. 3 root 6 times root 2 would give me 3 root 12. Outside's 3, underneath the radicals is 12. Then I multiply over here. What do I get? 3 times I, and there's a minus here, so minus 3I, and that would be root 60. And let's see what we can do. This is 4 times 3, so that's 2 root 3 times 3. Over here, 60 is 4 times 15. So that would be 2 root 15. And then remember, it's all about kind of remembering, bring these things down. Don't forget about coefficients, little things like that. So that gives me 6 root 3 minus 6I root 15. And that would just be your answer. Once again, this is a setup of a complex number. A complex number has a real part and an imaginary part. So this has an I and that doesn't. So they couldn't be combined anyways. So we just keep them separate. And that is the final answer. So just little things, distributing, everything that we already kind of know about. But we just want to make sure we're not making those little mistakes. And let me just do one more from that page, and then we'll look at the division stuff. I felt like the division was kind of the last thing, and I'm going to be honest, my brain was like not working those last few days. Quarantine's no joke, man. I like never want to go back to my house again. So I'm going to look at number 65. I was just leaving that in case anyone still needed it while I write the next one. Then we'll look at some of those divisions. Okay. I just want to do 65. I know it pops up when we eventually take that take-home quiz next week. I'm going to erase the bottom. So just as a reminder, just little setup things that we've done before. If you see a binomial being squared, you are going to take that binomial and multiply it by itself. So please don't just start squaring everything. You square something, you multiply it by itself. Then we have a big old distributing problem. So let's see what we got. That would give me 16. That would give me plus 8i root 3, right? Because the 4 times 2 gives me the 8 and everything else is going to stay the same. And then when I do inside here, that gives me plus 8i root 3. And then last but not least, when I do this times this, 2 times 2 is 4. I times I is I squared. And root 3 times root 3 is just going to be 3, right? Because it would be the square root of 9, which would be 3. So whenever you multiply a radical by itself, you just kind of end up with a number underneath. What a beauty. At this point, I always kind of go to this last term where there's some stuff I can combine, and I do that next. I see I have 4 times 3, I know that's 12. And once again, I always need to take care of that I squared. I squared is going to be replaced with -1. So this is actually just going to turn into minus 12 if I combine those terms. 4 times -1 times 3. And now I can add and subtract. 16 can be combined with -12 to give me 4. And then 8i root 3 plus 8i root 3 would be plus 16i root 3. Excuse me, my answer. Yeah, that's fine. Some people tend to say like, oh, this has a common factor. If you want to do that whole deal, you can and take out the 4, but don't feel like you have to. That's just saying that there's a GCF. You don't need to write it that way unless you really want to, but so I'll leave that one up for a second. I want to give everyone a minute to like recompose yourselves. I want to go over some of the division ones because I feel like I kind of rushed that one at the end there, Anya. And that is an important concept that we're going to be seeing. And then we'll just see a few solving equations. And then that will be our life today. But I know it's hard. Sometimes I get my own little world up here. I'm going to give you guys a second to breathe, so I'll give you a minute. By the way, wear your masks. God, there's one 4-year-old really like did some damage. One kid came to my daughter's preschool class and that made me stay home, which affected you guys, which affected my husband's work, and there was 20 more kids. So, wear your masks, take it seriously. Especially now, I feel like it's a little cray. All right, so I do want to spend a few extra minutes on division. So the multiplying, we've distributed a million times. We've done stuff with radicals before. So if you're still having problems or you have any questions, feel free to ask them, but I'm kind of just going to do my thing. Because as I was checking people, it looked like you were semi-okay with that stuff. So I'm, once again, just kind of looking at a few problems. So I'm going to look at number 70. And it says -3 divided by 5i. I'm just going to write it as a fraction, -3 over 5i, just as a heads up. So our big thing with division, and you'll see this a lot, like I do this in trig like every day. When we are simplifying anything, we never want radicals or square roots in the denominator. So what happens is you really can't have i's in denominator since they represent square roots. So a little funky. So when we give a final answer, you never want an I in the bottom of a fraction. So we have a way we can deal with it. So we're going to multiply. So basically, since I want to cancel that I can take what I want to cancel, which is the I, and I can multiply by that over itself. So what I'm really doing is multiplying by 1, because anything over itself is just 1. So I'm technically not changing the value of this. I'm just kind of moving things around and finagling it how I want to. And you'll kind of see what happens as we do so. So I'm going to multiply just across. I get negative 3 times I, which is negative 3I. And then I get 5I times I, which is 5I squared. So once again, I planned this very carefully because I know that I squared represents negative 1. And I can replace it with negative 1. So I end up with negative 3I over, that would just become negative 5, right? Because that's pre-multiplied. And I would in the end say, okay, 2 negatives make a positive, and my final answer would be 3I over 5. So take a moment. Just remind yourself what we're kind of doing there, and that was explained in the notes, so you might have it written down somewhere. Whenever you see a fraction or you're dividing something, you never want an I in the denominator, so that's what we're taking care of. To do so, we're going to multiply by I over I. Once again, I do that to get I squared, which turns into a negative 1, and that's just all about simplifying from there. What a beauty. So if I'm doing 71, let's say,
Yes.
we're dividing, what I would do is I would always reduce before you, excuse me, I would reduce before I start to simplify. So let's reduce this. That would just be negative 2 over 3I, right? Let's just make our life as easy as possible. Not have to deal with the bigger numbers. Same step. So that's a nice thing. You say, I don't want an I in the denominator. I'm going to multiply by I over I. And I get negative 2I over 3I squared. Excuse me. I squared becomes negative 1. So I get negative 2I over negative 3. Which simplifies to 2I over 3. So technically, those have the same exact value. We're just rewriting it so there's not an I in the denominator. We call that rationalizing the denominator. How beautiful. So I like those ones. Those ones are nice. They all can't be nice, unfortunately. So what happens is as we look down, some of the denominators have more than one term. So we have to know how to kind of deal with those. So let's look at 72. And we'll go from there. Sorry, I'm just we're always looking at that chat. If you need anything, just let me know. So 72. So when you're dividing, once again, we don't want this I, but I can't just multiply by I over I, because when I distribute, it will be a big hot mess, and I'll still have I's. So if you have 2 terms down here, we multiply by the conjugate. So the conjugate means I take these 2 terms, but I change the sign just that's in front of I. So this 3 stays the same, but I change the sign that's in front of I, and then I put that over itself. So it almost looks like the same thing. The only difference is the sign in front of I changes. And now we got a whole bunch of distributing to do. So once again, these steps are kind of review scheme. It's more the setup that you need to be careful with. So when we distribute here, we get what? 15 minus 10I. Okay, that was pretty easy for the numerator. And then this is what the reason we do this in the denominator. We get 9 minus 6I plus 6I minus 4I squared. The whole reason we did that is so that minus 6I plus 6I cancels because we don't want those i's. This I squared turns into a negative 1. So technically a negative 4 times negative 1 will give me plus 4. And now I can see what I'm left with. I have 15 minus 10I over 9 plus 4 is 13. What a beauty. That can't be simplified anymore because there's no common factors. So you just leave it like that and you're kind of done. There's some other ones that are a little, like, there's a few other things. You just simplify as much as you can. So you might have to distribute or combine like terms, but in the end, you're gonna end up with kind of that same original setup, and multiply by the conjugate. So just take a second, see if there's any questions. Once again, I know when you're at home, it might take you an extra minute or two. So I'm gonna give you a second to set yourself up. And then we are gonna do something new. Here's what I'm gonna do actually, while I'm giving you a second. I'm gonna scan these few pages. Because if I don't do it now, I will forget. Let's be honest, it's Friday. And I never know what's going on anyways. Okay. And a new one, I'm gonna take a picture. Did anyone go back in? So I corrected those. Sorry, I'm trying to scan this. This is not working. What's going on? Okay, maybe I won't scan right. Why is this thing putting out of me? I don't know. Okay, never mind. I'll do that later. I think there's like a fold in the paper. It's getting angry at me. Anyways, did anyone go back in? Mia, did you go back in and look at that quiz? Okay. Did anyone else go back in and look at that quiz? Could you see like my markings on it? Can someone just tell me in the chat? Yes or no? Or did anyone even check it? Or did anyone care? Don't all type at once, guys. Okay, I'm gonna. Go back into that quiz that I gave back. You had done it last Thursday. I just wanted to see if you guys could see what I had written on it. So at some point, see if you can and let me know. Because I use a program called Kami, Kami. Okay, I didn't know if it was like something special, but I'm pretty sure you can see it. So go back in and check it, because you should be able to see like check marks or circled stuff, minus or whatever. You should be able to see it in there. So do that at some point.
I can't see it, but it may be because I'm on my phone.
Oh, okay, because she's on the phone. All right, yeah. We'll try later. We'll see what's happening. Okay. So let's do a little bit with solving, and then I'm like pretty much almost caught up. So once again, thank you guys so much. It's very nice. You guys make my life a little bit easier in the fact that like, oh, okay, it's Kira can see it. Thank you. So go in and check it. But I might use that in the future, so I just want to know. But you guys do make my life easier because one, you don't complain, which I very highly appreciate. Because I have some other complainer classes. And two, I just know you're gonna like actually like put effort in, and that's always nice. So thank you. So let's do those, a little bit of solving. We'll kind of do the basics today, and then we'll look at a little bit more complicated ones next week on Tuesday. And then Tuesday night, you're going to get a take home. But then Wednesday, I'm like not gonna give you an assignment. I'll just say like work on your take home. So it's not super long. It's more just checking in with this first part of the chapter, and we'll go from there. So we are going to be solving some equations. How exciting. And we're going to be using the square root method. All right. So here's a general example, something you probably know how to do. You guys did this last year, but let's be honest, who can remember anything from last year at this point? So a general example would be something like this. So you have some sort of equation. It is a quadratic. There's no linear term, so there's no just regular x term. There's x squared, and then there's constants, but there's no x term. So if there was an x, you'd have to do something else. But in this case, we can use square roots to solve it. So if we're solving with square roots, our main goal is to isolate this x squared term, so whatever's being squared, as your first step. So I would subtract 1. So that's not bad. I would also divide by 5. So when I say we're using square roots, you need that x squared to be isolated before you can actually use them. 125 divided by 5 is 25, so that's not bad. And now we can take the square root of each side. So the reason I can do that is because the square root cancels the squared. The big thing with this, we do have a quadratic, you need 2 answers. So please do not just write your answer is 5. Your answer is plus or minus 5. So please just make sure you're giving both answers. You can either write plus or minus, or you can write positive 5 comma negative 5. But for a quadratic, you should have 2 answers, so just as a heads up. So that's kind of review. It might have been a while, so obviously we'll practice some more, but just as a general kind of what the process is. Now let's look at an example that has imaginary numbers, because that's kind of the goal of this chapter. So with imaginary numbers, you'll have something like this. Now it's going to look exactly the same. So that's the thing about these is you're kind of just going like, I don't know what the answer is going to be, so you just do your best. The idea is the same. We want to isolate this x squared before we can take the square root. So I'm going to subtract 4. Two. I'm going to divide by 2. Nothing more than just isolating a variable. And once I get to here, I am going to take the square root, because once again, the square root cancels the squared, and we're just left with x equals. And the only difference between this one and this one is in this one, I'm taking the square root of a negative, whereas this was a positive. Same idea though. We know the square root of 16 is 4, and since that negative is there, our answer is 4i. And you need that plus or minus in front, or you can write a positive and a negative. So really the actual solving steps are the same. It's just in the ones from this chapter, a lot of times we will end up with negative square roots. So we will have i's in the answer. Any problems? Okay, sorry, just checking. All right, so let's look at just a few examples. Also, like, just lost all my memory for life. Okay, so here's just a more basic one, and then we're going to kind of look at some different setups as well. So the main goal is to understand the process. So then if something changes in our setup, we are comfortable with it. So this is kind of a more basic one. Okay, so I look at it, and it would be under a section that says solve or solve using square roots. And we would say to ourselves, okay, I want to isolate the x squared. So I'm going to subtract 1. And I'm going to divide by 7. I feel like 119, what a weird number, but it is divisible by 7. So negative 119 divided by 7 is negative 17. Oops, that's x squared. So 2 squared. Okay, so I get to here, I say to solve for x, I'm going to take the square root to cancel the squared. So x is going to equal, the first thing I'm going to do is write plus or minus so I don't forget. I look under my radical and I say, okay, there's a negative, so I know there's going to be an I here. I'll throw that I there. And then the square root of 17, I'm saying, well, I can't do anything. So that's just how my answer would be written. X equals plus or minus I square root of 17. So not every radical you can break down. So just as a heads up, just make sure that I does come to the outside to take care of the negative. Any problems? Okay, I'm doing next to it, sorry. I keep feeling like I erase fast and I feel dumb. So here's a little different setup. Not that it's necessarily harder. We know that. That's called a proportion. We just did a whole fraction chapter, for goodness sake. So to solve a proportion, we're going to cross multiply. I'm going to get x squared equals, and that would equal negative 8. Okay, so that was a pretty easy setup. To get x isolated, I'm just going to take the square root of each side. And x is going to equal Remember, I always just put plus minus. When you're using square roots, do not forget it, because if you forget it, you only have half of an answer. I know there's gonna be an I in the answer because that comes from that negative, and I also need to break down the square root of 8. So the square root of 8 is 2 root 2, right? So that would be 2I root 2. What a beauty. Okay. So let's look at this one. I'm gonna give you one or two to try. All right, this one's a little bit of a different setup. All the other ones just have like x squared, whatever. This is x plus 2 in parentheses squared equals negative 25. And we said the main concept is we are using square roots to cancel out that squared, and I need to isolate it before. So as you can see, this entire thing is being squared. So I can't move that 2 yet. The 2's stuck in those parentheses. Before I can do anything to those parentheses, I need to get rid of the square. So if there was something outside of here, in front, or over to the side, we'd have to move it. But in this case, the thing that is being squared is isolated. So I'm going to take the square root on both sides. I end up with x plus 2, because the square root and the square root cancel each other, and I'm left with what's underneath or what's in the parentheses. I simplify my right side. Please do not forget, when I'm taking the square root, it's plus or minus, and then that would simplify to 5i. So we would write our answer as, we want x by itself, I'm going to subtract 2 from both sides. So you would write the answer as, you would just put this term out in front, and you would write it as negative 2 plus or minus 5i. So a little bit different way to set up the problem. Kind of funky with the plus or minus. It is just representing 2 answers. So we'll try a few more like that before we can wrap up. The ones get a little bit different with there's a few things that's being squared. We just want to make sure we're feeling comfortable with different setups. I think I just have 2 more for you here. Oh, we'll do this one. Why not? So it looks pretty similar to what we just did. The big difference here is we said we have to isolate whatever's getting squared, and the parentheses is what's getting squared. So basically we don't want anything outside of the parentheses. So I'm going to have to deal with this 4 as the first thing. Please do not distribute it in. You just want to cancel it. So since it's 4 times that, we're going to divide both sides by 4. Okay. So if there's anything outside of the parentheses, in this case, you do need to move it, which we did. Now we see the parentheses are being squared. So we're going to take the square root. That's the only other thing we can do to kind of break them out of there. We're going to take the square root of this side. We end up with 3x plus 1 equals. So I know there's going to be an I there. I'm writing that plus minus before I forget. But other than that, 2 I can't break down. So we would just write it as plus or minus I root 2. This is actually a step we're going to do a lot. Coming up pretty soon when we're completing the square. Now you just kind of solve this side like you would solve a normal equation. Subtract 1. Remember, we're going to write that right side a little funky. We're going to write it as negative 1 plus or minus I root 2. So basically you put it in front of the plus or minus just to represent the 2 numbers. And then the last step, you still need x by itself. We would divide everything by 3. What a beauty. And that, my friends, would be your answer. So solving with square roots, not terrible. In this case, there is, a few funky things going on with parentheses being squared and maybe things on the outside. So we will kind of deal with that stuff as it comes. Sorry, I'm just trying to check if there's anything else. I still have 10 minutes. Okay, so here's what we're gonna do. I still have, yeah, still have 10 minutes. One of these days I'll learn the schedule and we'll just change it on me. So here's what we're gonna do. You're going to open that problem set. We've been working on it, so it should be familiar to you. As of right now, you have up to number 76 done. We are going to look at that next section. So from 77 to basically 101 are all solving different fun equations. All of them are using the square root method. So that's delightful. Some of the ones at the end, like 99, 100, 101, they get a little more complicated. We will go over those ones. But what I want you to do right now is kind of open that. You can just go, if you don't have it in front of you, you can go to Google Classroom. It's posted the last few days. I didn't repost it today. And you are going to try a few. Now, I'm going to say on Wednesday, so I'll give you plenty of time. Basically, this needs to be done. The last 4 problems we'll save for next week. But besides that, all the other ones you should kind of be working on. So if you have a study or a few extra minutes, you're trying these. And if you've skipped anything up till now, you're making sure to go back and try it. So right now, you're opening your problem set. You can go into Google Classroom if you didn't want to print it, that's fine. You're starting with 77. You're just trying a bunch as you go. Make sure you're putting those plus minuses in your answer. Some of them don't have eyes, so I feel like that freaks people out. That's okay. So some of them do not have eyes in the answer. They're just regular old solving. So you're working on that now. So for the peeps at home, I'm gonna stop this.